Mid-February 1943. Sidi Bou Zid, Mamoun Ahmed. In mid-February 1943, Sidi Bou Zid, Tunisia. An M4A1 Sherman tank, having been seized, came to a halt in the desert sand, with its American star still noticeable beneath a hurriedly applied German cross. Officers belonging to the Heavy Panzer Battalion 501 surrounded this captured vehicle, already opening their notebooks. The single intact and fully functional American tank obtained during the fighting at Sidboid would set off a confidence crisis among German engineers that would reverberate throughout their tank design efforts for the remainder of the conflict. The equations governing armored combat were on the verge of transformation, not due to superior armament or thicker protection, but from an automotive reliability the Germans had never pursued, a mechanical excellence that steadfastly endured. On its hull, the tank carried the designation War Daddy II. Carrying serial number USA 3,067,641. It had been built by Leimer Locomotive Works and assigned to Company G, 1st Armored Regiment, 1st Armored Division. Members of a German reconnaissance group piloted this Sherman for 350 kilometers over the North African deserts to the port of Espifax, a trek lasting 4.5 days. Each kilometer brought revelations that challenged German notions about American manufacturing prowess. The engine remained at a safe temperature the entire time. The transmission never malfunctioned. Performance of the final drives stayed constant. German crews who were used to frequent breakdowns, even over short distances, observed with increasing discomfort as this adversary tank persistently operated without issue through difficult terrain and conditions that would typically cripple their machinery. Upon arrival at the port, War Daddy II was loaded onto a freighter heading for Germany. Explicit directives from the Army Weapons Office had been issued. The tank was to arrive at the Kummersdorf testing grounds whole and functional. German intelligence had received incomplete reports regarding the extent of American tank manufacture. Yet having the actual vehicle before them made those production figures tangible in a way that paper statistics never quite did. The Sherman embodied mass manufacturing on a scale beyond Germany's capacity. It was constructed following automotive engineering standards Germany had yet to master. As the ship progressed northwards across the Mediterranean Sea, Wehrmacht engineers set up a series of tests that would expose difficult truths about both their own shortcomings and American strengths. Spring of 1943, the Kummersdorf Proving Grounds, Brandenburg, Germany. War Daddy II was unloaded from the transport railcar labeled Zugfahrts 259, also displaying the German license plate WHO 58941. Test engineers had already marked the tank's armor with measurements of thickness and angle, applying precise stencils that recorded data for their thorough analysis program. The Kummersdorf German Army testing site, positioned 25 kilometers south of Berlin, acted as the central location for trials involving both German equipment and captured Allied vehicles. At this site, detail-oriented engineers assessed, experimented, and studied components such as track tension and transmission performance, compiling detailed observations in extensive technical documentation. The Sherman faced what was said to be the most thorough automotive investigation that German engineering expertise could construct. The opening evaluation from German test engineers involved numerous expert teams from several technical specialties. Each component was photographed from numerous perspectives. All clearances were measured with exact tools, and the building methods, strikingly plain compared to German standards, were carefully noted. Powertrain experts immediately focused on the transmission, while straight-cut gears, common in German tanks, demanded exacting tolerances and frequent servicing. The Sherman used herringbone-cut gears which distributed force among multiple gear teeth at the same time. This engineering choice, standard in American vehicle production since the 1930s, resulted in outstanding durability without relying on strict manufacturing tolerances. German engineers had previously considered herringbone gear systems too challenging for large-scale production given their industry resources and worker training. However, American factories had achieved mass production numbering in the thousands. Testing proceeded with fundamental automotive evaluations meant to push each mechanical subsystem under carefully controlled scenarios. The engineers steered War Daddy 2 through a set of obstacles that imitated combat scenarios, logging fuel usage, tracking engine temperatures, and observing transmission activity across varied loads and ground conditions. After every round, parts were taken apart to inspect patterns of wear, checking for markers of material stress, lubrication issues, or possible design flaws. The outcomes were in total opposition to German armored doctrine's beliefs about the required compromises between reliability and performance. The Sherman delivered solid results across all tests and was outstanding in one area German tanks rarely met: operational range without needing maintenance. Scrutiny of the powertrain exposed foundational contrasts in engineering mindsets that clarified much about American and German strategies. The Sherman tank's transmission was equipped with 5 forward gears in addition to a single reverse gear, and gears 2 through 5 were synchronized, removing the necessity for double clutching during ordinary driving. This feature resulted in the tank being nearly as straightforward to operate as typical civilian cars, so drivers required only a modest amount of special instruction. In contrast, German tank crews dedicated significant effort to mastering intricate double-clutch procedures and precise throttle adjustments to prevent transmission harm. The Sherman's engineering took into account that regular troops possessing standard automotive skills would handle these vehicles, whereas German tank development relied on the availability of extensively trained professionals. The Continental R975 radial engine installed in this Sherman showed exceptional resilience under diverse operating scenarios. Technical evaluations recorded that the engine delivered uniform output despite temperature conditions that could have led German power plants to overheat or experience power shortages. The tank's simplified cooling mechanism nonetheless achieved impressive effectiveness. Its air filters coped with desert sands without the recurrent blockages that regularly hindered German armor in North Africa. Each element demonstrated a philosophy that emphasized practical reliability above abstract perfection. June 6 and 7, 1943. Hille-Lee Artillery Proving Ground. Reich Minister Albert Schar arrived to oversee a significant conference on armaments, attended by figures from weapons manufacturing and high-ranking Wehrmacht officials. Events included uphill performance tests pitting German and Allied tanks taken as war prizes against one another. War Daddy 2 was presented beside the newest German machines, including a Panther ACEF DM model just completed in the factory, as well as a Ferdinand tank destroyer symbolizing the zenith of German armored vehicle design. Schar, who oversaw Germany's weapons output and answered to Hitler alone for results, needed first-hand knowledge of what American factories were manufacturing and how German tanks compared to their adversaries' equipment. The trials would reveal truths that neither Schar nor German tank engineers had hoped to confront. The Sherman ascended the graded slope easily. Its manual gearbox, offering 5 forward selections with synchronization between second and fifth, allowed shifting seamlessly. Its engine sustained steady power throughout the climb. The driver maneuvered with assurance, displaying the user-friendliness that would come to define the Sherman. The Panther came next, propelled by its more powerful Maybach HL230 engine generating 700 horsepower, enabling it to achieve performance similar to the Sherman but with greater strain and less ease. The 65-ton Ferdinand, featuring a highly advanced electric drivetrain, failed midway up the hill, coming to a stop. Speer observed as a recovery team endeavored to get the tank moving again, the awkward breakdown playing out in full view of dozens of leading officers and defense industry representatives. Many years later in his memoirs, Speer described Sherman's capabilities he witnessed during his inspection journey through Italy in October 1944. He observed that accounts concerning the Sherman's cross-country movement were extremely positive, with the tank scaling mountains that German tank specialists had deemed impassable for armor. He credited this to the Sherman possessing a highly powerful engine relative to its mass, which granted it off-road mobility on flat terrain that was clearly superior to German tanks. This advantage had been specifically mentioned by the 26th Panzer Division. Such findings from Germany's Minister of Armaments were taken very seriously within Wehrmacht circles. The public evaluation in writing was published in the Das Reich newspaper on June 27, 1943. This publication characterized the Sherman as one of the distinctive achievements of the North American laboratories and lauded it as an especially noteworthy outcome of the North American steel sector. The report pointed out that the initial features to catch the eye were mass production techniques and the realization of the nearly audacious standards of the North American motor industry. The article referenced the gyro-stabilized cannon as the pioneering effort of its sort ever made, recognizing American advancement in this field. Although these public remarks were deliberately crafted for propaganda and to avoid sounding defeatist, they still hid the private concerns that were spreading through German engineering teams. American armored vehicles were not just sufficient. They were, in fact, more fundamentally well designed for prolonged operations in the field. Meanwhile at Kummersdorf, organized testing proceeded throughout the summer and into the fall of 1943. Specialists recorded the Sherman's service range by holding prolonged trials that drove the tank to its operational limits. They registered operating distances over 2,000 kilometers before significant maintenance was necessary, nearly quadruple what initial Panther models could manage under field circumstances. They assessed the transmission's effectiveness, discovering results that were superior to any German tank, with power loss through the drivetrain much lower than similar German machines. They studied the coordinated manual transmission, which enabled seamless and uncomplicated gear changes, eliminating the need for double clutching or careful synchronization of engine speeds required by German transmissions. The final drive then provided another surprise that contradicted typical German engineering beliefs. Panther tanks used final drive mechanisms based on those from the Tiger, a design vulnerable to failure when stressed. This approach utilized straight-cut gears housed in containers that could not withstand the loads of the 45-ton tank. German repair crews serving in North Africa and on the Eastern Front relayed issues of final drive malfunctions, often forcing Panthers to be left behind after fairly short trips, sometimes of less than 100 kilometers. In contrast, the Sherman's final drives, made utilizing the identical herringbone gear design as the transmission, almost never broke down, even with extended combat use that would destroy comparable German parts. Decades later, restoration efforts discovered Sherman final drives that required no repairs after prolonged storage, proving that their design tolerances surpassed the immediate need by significant margins.